Hi everyone. This lesson is on 2 ways to use the unit circle. We've already gone over the 1 way to find exact trig values, but we're just going to recap that and then move on. So we're learning to use the unit circle to find exact trig values. That's what we did in the last lesson. And then we're also going to learn how to use the unit circle to solve simple trig equations. So what we went over the last time, the first way we can use the unit circle is to find exact trig values of angles related to 0, 30, 45, 60, and 90. We know that on the unit circle, the ordered pair on the outside of the unit circle, so any one of these ordered pairs has an x value and a y value. And the x value represents the cosine of angle theta, and the y value represents the sine of angle theta. And again, we learned that that was because cosine is x over r, but on the unit circle r is 1, and sine is y over r. And on the unit circle r is 1. We also know that the tan of angle theta is the y value divided by the x value from the ordered pair, and the cotangent of angle theta is the x value divided by the y value. And then we could also find secant theta by inverting the fraction for cos, because secant and cos are reciprocals. And we can also find the cosecant by inverting the fraction for sine, or inverting the y value. And all of this can be done without a calculator. So find the exact value of each. So the sine of 330 is going to be the y value at 330. So we're going to go to our unit circle, look up the y value at 330, which is -1/2. And there is the exact value of the sine of 330. Tan of 150, we know that's going to be the y value divided by the x value at 150. So 150, here's the y, here's the x. So 1/2 divided by -√3/2. And we learned that if we've got the same denominators when we're dividing fractions, they can divide out, and we're left with dividing the numerators. Usually that negative sign could go either with the numerator, the denominator, or even with the fraction bar. We usually put it with the numerator. So there's the tan of 150. Sec of 30, so we're going to look, sec is related to cos. So here's our x value at 30 degrees, but to find the sec, not the cos, we would invert this. So it'd be 2 over the square root of 3. So a little refresher on what we did earlier. Moving on to the cosine of -420. First, I would find the cosine of an angle that's on our circle. So I'd add 360. So cos of -420 plus 360 is -60. But we would still want to add 360, so we get a positive angle. So that gives us 300 degrees. So now we're going to look at 300 degrees on our unit circle, and it's the cosine that we want, so we want the x value at 300, which is 1/2. Tangent of 180, so that's the y value at 180 divided by the x value at 180, so 0 divided by -1, which is 0. Sec squared of 570, so first we're going to figure out where that is on the unit circle by subtracting 360. So 570 minus 360 is 210. And remember that it's being squared. So first of all, we're going to look at 210. We're going to look at the x value, because sec is related to cos, and we're going to flip it upside down. So we're going to change it to -2/√3. That would be the sec, but we want to square that because it's sec squared. So we're going to square the top and square the bottom. So negative 2 squared is positive 4, and root 3 squared is 3. So sec squared of 570 is 4 over 3. So there's a review of how to use the unit circle to find exact trig values without using a calculator. Okay? And giving them in exact form with square roots or fractions, not decimal form. So the second way to use the unit circle is to solve a simple trig equation whose solutions are angles on the unit circle. So I consider it kind of working backwards. So we're going to be looking at a simple trig equation and figuring out the solution, which is going to be an angle. And the cast rule we can also apply. It's going to tell us what quadrants on the unit circle to look in. Okay, again, this is important for grade 12, that we start off learning to solve these trig equations. So, solve each trig equation over the interval 0 to 360. So here is a trig equation. Sine of theta is equal to 1/2. So in any equation, we want to figure out what is it that we're trying to solve for. So what's the variable or the unknown? In our case, the variable is theta. So we want to solve for theta. And we learned when we were just doing angles and quadrants how to solve this by taking the sine inverse of both sides, which is a fine way to do it. But we could be missing solutions, especially when we're asked to find all the solutions between 0 and 360. And next year you'll be looking at finding solutions over different intervals and not just 0 to 360, but grade 11 we concentrate on that. So how do we use the unit circle? Well, we know that on the unit circle the sine is the y value. So we're looking for where on the unit circle the y value, because sine is the y value on the unit circle, is 1/2. And we're also looking and seeing that the sine value is positive. So by the cast rule, we should be finding positive values for sine, positive 1/2, in either the first quadrant or the second quadrant. So the cast rule, you don't need to use it, it just narrows down where you have to look on the unit circle. So then we get our unit circle out, and we want to look for where in the first and second quadrant is the y value or the sine 1/2. So you can see right here at 30 degrees, the sine is 1/2. Okay? Now the great thing about the unit circle, if you color coded it, is the other place in the second quadrant should be the same color. So for me, the 30-degree triangle is green. Over here, the related 30-degree is 150. And then if you look at 150, again, the y value is 1/2. So those are the two places between 0 and 360, 30 degrees and 150 degrees, where the y value is 1/2. The other green ones, you can see the y value is negative 1/2, which is different. So the two solutions between 0 and 360 where the sine of an angle is positive 1/2, or when that angle is 30 degrees, or when that angle is 150 degrees. So then we can just say, therefore, theta is 30 degrees or 150 degrees. So we got that from the unit circle. If you have the unit circle memorized like over the years, like I do, then you can solve those simple trig equations in your head without using a calculator and drawing out diagrams, which is another way that you could do it if you want to. So in this case, we're looking, the equation, its simple trig equation is, where is the cos of theta negative root 3 over 2 between 0 and 360? So again, the cast rule helps us to know where to look on the unit circle, because we're looking at cosine, and we know cosine is positive in the fourth and the first quadrant, which means it's going to be negative here and here. So this is where we're going to look. And cos is related to the x value on the unit circle, so we're going to be looking, where is the x value negative root 3 over 2? What angles? Theta. Remember, theta represents an angle. Some people like to write angle theta is, okay? It's fine as well. So where is it negative root 3 over 2? And the cast rule told us to look here and here. We're looking at x values. So x value negative root 3 over 2 is at 150. And also 210 has an x value of negative root 3 over 2. So therefore, theta is 150 or 210 degrees. Those are the two possibilities for the angle between 0 and 360 that have a cosine of negative root 3 over 2. Okay, cosecant theta is negative 2. So what I would first do is I like to change them to be in terms of either sine, cos, or tan. So if I change cosecant theta to sine theta, so I can use the cast rule, then I change negative 2 to negative 1/2. I flip it upside down. So now I can use the cast rule to tell me what quadrants on my unit circle to look into. So sine being negative, so sine's positive here and here, so sine's negative in the third and fourth quadrant. So I'm looking for sine being a y value, negative 1/2 in the third and fourth quadrant. So the y value, there at 210, and then I also know in the fourth quadrant, I should also have it, the same green one again, negative 1/2 at 330. So it should be theta equals 210 degrees. Don't forget degrees, they're like units, and 330 degrees. Okay, cosine of theta equals negative 1. Again, here's our cast rule. So cosine is positive here and here, negative in the second and third quadrant. And we're looking for the x value, because it's cosine, to be negative 1. And we know the 1s and 0s happen on the four corners, if you want to call it that, or the origin. So the x value is negative 1 at 180, not anywhere else. So there's just one answer for this. So theta is equal to 180 degrees. Tan of theta is negative 1. So I'm going to put a little star here. Tans are the hardest ones because if we go back to our beginning here, cos and sine are easy, which also make secant and cosecant fairly easy because you can change them by flipping them into being in terms of sine and cos, and they're just either the x value or the y value or the inversion, okay? But tan's a bit more complicated because it's the y value divided by the x value. So this is asking, where is, in your unit circle, the y value divided by the x value, negative 1? So first of all, the cast rule can help us narrow it down a bit. So tan is positive here and here, so it's negative in the second and fourth. So where in the second and fourth quadrant do I divide the y value by the x value? Remember, tan is the y value divided by the x value, and end up getting negative 1. So I could look here, if I divide root 3 over 2 by negative 1/2, I'm not going to get negative 1. But here, if I divide 1 over root 2 by negative 1 over root 2, they're the same except for a negative sign, so I am going to get negative 1. So 135 is one of my answers. And the cast rule tells me to look in the second and fourth quadrant, so that should be true also at 315 degrees. The y value divided by the x value, again, should be negative 1. So my solution should be 135 degrees and 315 degrees. So tans take a little bit more thinking because you have to think about dividing them. Okay, so we're on sec theta is negative root 2. So as soon as we see sec, we're going to change it to its related, which is cos. But that means we have to flip this one upside down, which is going to make it negative 1 over root 2. So we're looking, so here's a cast rule. Where is cosine negative? Second and third quadrant. And then we also want to know where it's negative 1 over root 2. So we're looking for x value of negative 1 over root 2. So that's at 135 and also at 225. So theta, angle theta, is either 135 degrees or 225 degrees between 0 and 360. Okay, so now they're getting only just a little bit harder because the sine, cos, or tan isn't isolated. You have to do a little bit of reverse bedmass first. So we're going to subtract 1 on both sides because we want to try to get the cos theta part by itself. And then divide both sides by 2. So now we've got it down looking to a simple trig equation again, a very simple one. Apply our cast rule. We want to know where cosine is negative. So second and third quadrant, and it's cosine, so we're looking at the x value being -1/2. So in second and third quadrant, the x value being -1/2 is at 120 and then at 240 as well. So theta equals 120 and 240. All right. Again, we'll get cosecant by itself, and then we'll change it to sine. So first let's add 2 to both sides. Divide both sides by √3. Oh, sorry, this should be cosecant. So we've got cosecant theta equals 2 over √3, but we know cosecant's related to sine. So if we change cosecant to sine, we change 2 over √3, we flip it upside down, and it becomes √3 over 2. And it's positive, so we want to know where is sine positive, first and second. So first and second quadrant, sine is the y value, √3 over 2. So that's going to be at 60 and 120. The y value is √3 over 2. So therefore, theta is 60 degrees or 120 degrees. √3 cotan theta minus 1 equals 0. So I'm going to add 1 to both sides. Divide both sides by the square root of 3. But then to use the cast rule, I want to switch cotan to tan, which means I have to flip this side upside down. So √3 and √3 over 1 are the same. Positive, so where's tan positive? First quadrant and third quadrant. So again, tan's a trickier one. You've got to think about where the y value divided by the x value gives me √3. Or √3 over 1. So let's look in the first quadrant first. So 1/2 divided by √3 over 2. Again, you can divide the 2's out. That's going to give you 1 over √3, not √3 over 1. So it's not 30 degrees. 45 would be 1 over √2 divided by 1 over √2 would be 1. So then, √3 over 2 over 1/2, yes, when I divide those out, the 2's cancel, I'm going to get √3 over 1, which is √3. So 60 degrees is an answer, which should mean that 240, following down to the other quadrant, quadrant 3, should be the same. So I have a negative divided by a negative, which gives me a positive, and then √3 over 2 divided by 1/2 gives me the √3. So 60 and 240 should be my solutions. So therefore, theta is 60 and 240 degrees. Okay, so continuing on, got a few more to try here. 4 tan theta plus 4 equals 0. So subtract 4 on both sides. Divide both sides by 4, and we get tan theta is -1, cast rule. Tan is positive in the first and third, so it's negative in the second, fourth, and fourth. And we want it to be -1, so we want the y value divided by the x value to give us -1. So again, in the second quadrant, y divided by x, that's not going to give -1. But this one is, so 135. And then in the fourth quadrant, 315 should also work. Y divided by x should give us -1, and it does. So our solutions are 135 degrees and 315 degrees. For K, 4 sine squared. So this is the first time we've seen a squared. We're going to try 2 of these now. So first we want to use reverse BEDMAS, add 3 to both sides. Divide both sides by 4. But now we've got this squared here. So to undo squared, we square root the whole thing. So make sure your root sign goes all the way down to the denominator. But we also need a plus or minus here. So sine theta is positive or negative. Square root of 3, but square root of 4 is 2. Since we have the plus or minus, positive or negative, sine can be positive or negative, we're going to check all 4 quadrants. And because it's sine, we're going to check all 4 quadrants to see whether the sign is either positive root 3 over 2 or negative root 3 over 2. So we should have 4 solutions between 0 and 360. Once we find our first one, they should be color-coded. So looking in quadrant 1, for the y value, because it's sine to be root 3 over 2, it's the 60 degrees. And so all of, in my case, the pink ones should work. So if I look in the second quadrant, the y value is root 3 over 2. Third, at 240, the y value is negative root 3 over 2. And in the fourth quadrant at 300, the y value is also negative root 3 over 2. So the 4 solutions are 60, 120, 240 degrees, and 300 degrees. So all of those angles have a y value that's either positive root 3 over 2 or negative root 3 over 2. So all 4 are solutions. Okay, we can use the same technique for this last one, L. 3 sec squared theta minus 4 equals 0. So we're going to add 4 to both sides first. Divide both sides by 3. Square root both sides, plus or minus. So sec theta is positive or negative. So the square root of 4 is 2. Square root of 3 is not nice, so we're going to leave it. That sec, we want cos, because we want to use the cast rule. So plus or minus root 3 over 2. And we're going to look in all 4 quadrants because it's plus or minus. And we're looking for where's the x value. Either positive root 3 over 2 or negative root 3 over 2. So in the first quadrant, the first time we see the x value being root 3 over 2 is at 30 degrees. So for me, that's green angles. So if I look in the second quadrant, 150, I have an x value of negative root 3 over 2, 210 an x value of negative 3 over 2, and 330 degrees an x value of positive root 3 over 2. So those are my 4 solutions. So theta should be 30 degrees, or 150 degrees, or 210 degrees, or 330 degrees. So that's how you can use the unit circle to solve simple trig equations without using a calculator.